All right, in the last video, we started talking about functions, and we got through our definition of what is a function as well as an introduction to domain and range. In this section, we are going to talk about intro to function notation. All right, so let's go ahead and talk about that. Okay, so over the course of your mathematical journey so far, you have looked at a variety of topics that essentially just expand on previous material. When discussing function notation, please note that we're doing the same thing. We are still looking at the same topics that we have seen before, but we are just changing the appearance. So if you think about when you talk about linear equations, sometimes they're written in general form, ax plus by equals c. Sometimes they're written in slope-intercept form, y equals mx plus b. These are just different ways to write the same information. So now let's talk about, okay, well, what does that have to do with function notation? All right, so first and foremost, function notation is a notation. It is nothing more than that. It is just a way to write an equation to indicate that it is a function, that each x value corresponds to only one y value, or that it passes the vertical line test. In an equation, we have x's and y's, and so in order to write an equation in function notation, we are just going to replace the output, or the y variable, with the notation f of x. We read this as f of x. Now the symbols f of x means the function evaluated at x. And this is one of the biggest things that we have to worry about. It does not mean f times x. This is not multiplication. All right, so what we have here is we have f of x equals y. And so from here, what we're going to be doing in this section is we're going to be playing around with the numbers that we're given. Are they x's? Are they y's? And so this is basically what we want to kind of keep in mind. If the number is inside the parentheses, it is an x value or the x coordinate of the point. Numbers that are on the other side of the equal sign are always y values or y coordinates. All right, so let's look at just some equations and how they translate to function notation. So for instance, if we look at this first one, we have y equals 3x minus 5. It's just a regular old linear equation. And all we do is we replace the y with f of x. And now this is the same equation written in function notation. Now, when we talk about equations, we were asked, historically we've been asked kind of two different questions. The first one was, okay, if I give you an x value and I want you to find a y value. So for instance, if I say, what is y when x equals 2? So what we do is we replace x with 2 on our equation and we find y. In function notation, we can go ahead and replace this statement with find f of 2. These are the exact same statements. So here, notice that we replace the x in our function notation with 2. And so what we will do is we will replace all of the x's with 2, just like we did when we are asked what is y when x is 2. All right, the second statement that we are going to kind of be playing around with is something along the lines of what is x when y is 7? And so in order to do this, we're just going to go ahead and say find x when f of x equals 7. And so when we say what is x when y is 7, basically what we do is we take our 7 and we plug it in for y. Similarly, in function notation, find x when f of x equals 7. We're going to take our 7, we're going to plug it in for f of x. So notice that we are doing the exact same thing that we've always been doing. All right, so let's talk about some other things in terms of functions. So first and foremost, function notation is, again, it just denotes that it is a function, it satisfies all the definitions of a function. One of the other benefits to using function notation is that we can use different letters to represent different equations. In equation form, we have to be told not only what are we looking for, but we have to be told which equation are we referring to. And so when we use function notation, we can label them differently. We can label them f of x, g of x, h of x, and you can, basically change this letter in front to whatever you want it to be. And we can say find g of 5. And so when we say find g of 5, we know what x is, it's 5, and we know which equation we're looking at because we want to look at the equation that is labeled as g. As mentioned earlier, functions are used to represent real-life scenarios. So over the course of this semester and future math classes, we will be looking at quite a few real-life situations and using functions to create equations as well as answering questions given either an input or an output. All right, we're almost ready to start some examples. Let's go over and just discuss a couple other things that we want to keep in mind throughout this section. Okay, so the first thing that we're going to, as I mentioned, that we're going to be doing in this section is we're going to be told, okay, if x is this, what is y? Or if y is this, what is x? So we will be asked, some other questions that we can be asked to find is find a minimum or maximum point. So the minimum or maximum point, this is the point that has the smallest or largest y-coordinate, so the lowest point or the highest point on the graph. And if you were asked for a point, you do want to answer it as a point. You do need an x, y in parentheses. Now, you can also be asked for what is the minimum or maximum value. And if you are asked for just a value, this is the y-coordinate of the minimum or maximum point. Now, not all functions will have a minimum and or a maximum. And so if you have no minimum or maximum point, then you just say none. The second thing that we might be asked to find is something referred to as the zeros. The zeros of a function, this is where the function is equal to 0, and so what we're looking at is something like f of x equals 0, or the y-coordinate is equal to 0. This is another way to kind of, this is related to x-intercepts. All right, so again, not all functions will have a 0 or an x-intercept. And so if there is no 0 or no x-intercepts, you can say none or no solution. Now, another thing that we do want to keep in mind is remember that in order to be a function, each x value can only map to one y value. And so when plugging in numbers for x, you will only have one answer because of the definition of a function. On the other hand, when you are plugging in numbers for y, or when you are being asked to find the x values, and you will notice that as you read these problems, it'll say determine the values of x, you can have multiple answers. And you will be required to list all numbers that satisfy the statement. All right, so now that we've looked at that, let's go ahead and start looking at our examples. In this section, we are going to look at tables, we are going to look at graphs, and we are also going to look at equations. So remember that when we look at functions, the inside number, this is the main thing you have to remember with functions. The inside number is always an x coordinate, and the outside number is always a y coordinate. So for instance, if I look at f of 0, 0 is an x coordinate. We want to know what is y when x is 0 in our table. So if we come over to our table, when x is 0, y is 2. So f of 0 is 2. Similarly, let's try one more. If we want f of 3, again, I want to know what is y when x is 3. So looking at our table, we're going to go to our x column. We're going to find where x is 3, and I want the corresponding y value. So f of 3 is equal to 5. Okay, now we can go the other direction. Now one of the things is when we go the other direction, we're always going to be told the following thing. Determine the values of x such that f of x is equal to 3. That means we are looking for x, so what are we going to be given? We're going to be given the y coordinate. So when we look at this, we have the whole f of x equals 3. Meaning I want to look in my column, my f of x column, and find 3. And I want to know what is x when f of x is equal to 3. We get x equals 1. Same idea, let's try one more. We want f of x equals 2, so I want to find where f of x equals 2. We're going to come to our f of x column, look for 2, and we get x is equal to 0. All right, the last thing that we're going to look at in our tables is something called determine the zeros. Determine the zeros, just to let you know, whenever you see this, we want to know when the function is equal to 0. So we're going to look for where f of x equals 0. So if we look at that, where are we going to look? We're looking in our f of x column. We get f of x is equal to 0 when x equals -2. All right, that takes care of our f of x function. So let's look at a couple more. If we look at g, first thing we have is evaluate the function. Remember again that numbers inside the parentheses, these are our x's. So what we want is g of 1. That means I want to know what is g of x when x equals 1. So if we look at our table, we have x equals 1 right here. we come across and we get g of x equals negative 3. So g of 1 equals negative 3. Same thing with g of negative 2. I'm going to start by looking for where x is negative 2. We come across and we get 0. So when x is negative 2, g of x equals 0. So g of negative 2 equals 0. All right, for the next question, we have determined the values of x such that g of x equals negative 3. So where is it equal to negative 3? Remember, we want to determine the values of x. That means that my negative 3, I'm looking for it in my g of x column. Well, the first one that we have is here. G of x is equal to negative 3 when x equals negative 3. That's not the only one. We do want to find all values of x. If we come down further in our table, we also have a negative 3 here. So it also happens when x equals 1. So we get two solutions. We get x equals negative 3 and 1. All right, let's go ahead and look at g of x equals 1. Again, I want to find where 1 is in our g of x column. We have it right here. We get x equals negative 1. All right, determine the zeros. Remember that determine the zeros means where is this thing equal to 0? So we're looking for 0 in our g of x column. So what do we get? We get x equals, we have a 0 here. X equals negative 2. We also have a 0 here. So we're going to have x equals 0. All right, last function that we're going to look at for tables, we have h of x. So for the first part, let's go ahead and find where x is negative 3. And we want to know what is the h of x equal to. So if we come to negative 3, we have h of x equals 4. Similarly, for h of 5, remember 5 is an x value. So we're going to have 5. We get h of 5 is also 4. Okay, let's go the other direction now. We want to determine the values of x such that h of x is equal to 4. So what are my values of x? Well, it's actually going to be all of them. So we get x equals negative 5, negative 3, negative 1, 1, 3, and 5. Okay, is this thing ever equal to 2? We want h of x is equal to 2, so we're looking for 2 in the right column. It never equals 2, and so what do we say? We say no solution. We want to determine the zeros of the function. Remember, that means our function is equal to 0. Is this ever equal to 0? No. So this is also no solution. All right, so that takes care of our tables. So now let's go ahead and look at some graphs. Okay, so again, same idea. Remember that when we look at graphs, we have a lot of points here, and we have every single point has an x-coordinate and a y-coordinate. So just remember that the inside number is an x, and the outside numbers are the y's. So when we look at f of 0, I want to know which point has an x-coordinate of 0, and I want to know what is the y-coordinate of that point. So remember, when x is 0, we do not move left or right. We're just going to go up or down. So if we look at our graph, here is x equals 0. We want to move along this line and figure out where the graph crosses. It crosses right here. And so we get y equals 1. F of 0 equals 1. Okay, f of 3. In order to find this, we're going to come over to where x is equal to 3. And we want to go along our graph to figure out where it crosses our graph. We're up here. This point right here has an x-coordinate of 3. We want to know our y-coordinate. Our y-coordinate is 5. So f of 3 equals 5. Okay, so again, we still have the same question going the other direction. We want to determine the values of x such that f of x is equal to 3. This is my y-coordinate now. So if we look for where y is 3, that's going to be going up and down on my y-axis. We're going to come across, and it looks like it happens right around here. This is at about 1.5. All right, what about f of x equals 2? Same thing, we want to go ahead and look at where y is 2. And we want to find our graph where it crosses, and it looks like it crosses right here. What is x? What is the x-coordinate of this point? It is 1. So we get x equals 1. Okay, that's determined the x values. The next thing we have is determine the zeros of the function. So remember again, this means f of x equals 0. This means y equals 0. So we are looking at going left or right. We are not looking at going up and down from our x-axis. So zeros, this is also another way to say what is the x-intercept. So if we go ahead and look for the x-intercept, our x-intercept is right here. What is the x-coordinate of this? This is x equals -2. Another thing that we're going to look at as we progress through this class is we're going to also talk about minimums and maximums. So notice here it says what point is the minimum and what point is the maximum. When you're being asked to find a point, then you want to write it in point notation. Another thing that can be asked is what value is the minimum or what value is the maximum. In that case, you are only wanting to include the y coordinate. But for this one, we want to know what point is the minimum. So our minimum, we are looking for our lowest point on the graph. Lowest point on the graph occurs here. We want both coordinates. So how far to the left did we go? We went 4 to the left and we went 3 down. So our minimum point is -4, -3. Similarly for our max, where is our maximum point? Our maximum point is right here. We want to know what are the coordinates. So my x, to get there, we're going to go 3 to the right and 5 up. So this is going to be 3, 5. All right, let's look at a couple more. If we look at graph 2, I want to know what is g of 1. If we go ahead and find 1 on our graph, this is an x coordinate, so that means I want to go 1 to the right. And if we go down, we end up at -2.5. All right, if we look at g of -2, again, -2 is an x coordinate. So we're going to go 2 to the left. And how far up do we go? It looks like we go up 5. So this is going to be -2. G of -2 equals 5. All right, g of x equals -3. Remember, we want to determine the x values, so that means that -3 is a y coordinate. If we look for -3 on our graph, we have an x coordinate of 2, so that means x equals -2. All right, for g of x equals 4, we're looking for 4 on our y-axis. If we come across, I'm going to say this is going to be a little less than -2. So I'm going to go ahead and say, let's go with -1.7. It's not halfway, but it's not all the way to -2. And so there is going to be a little bit of leeway on these if you have to estimate. If we go the other direction, we also have that it is equal to 4. Not only on this side, but it's also equal to 4 on this side. Same thing, it's not all the way to the tick mark, it's a little less. So this looks like, I'm going to say 5.8. And again, this is an estimate, so there is going to be a bit of leeway on this. All right, that takes care of our g of x. Now let's go ahead and determine the zeros. So again, remember we are looking for x-intercepts. We want to know, where is this thing equal to 0? Where is it crossing the x-axis? First one we have is right here. Looks to be about halfway between 0 and -1. So I'm going to go ahead and say -0.5. But we also have an x-coordinate over here. And I'm going to go ahead and say about 4.5. All right, we also have what point is the minimum and what point is the maximum. So minimum, what is our lowest point on the graph? The coordinates are there. It is at 2, -3. Maximum, well, if you note, this thing does have arrows that go up forever. And so it has no maximum. All right, let's look at a couple more graphs.